So we're going to be taking a look at drawing some iguanas today. In order to do this, we're going to be thinking a little bit about them structurally, and we're also going to be thinking of them as big lumps. And how do you handle big lumps? They like to kind of kerflump on the ground, and getting that sense of kerflumpness is going to help your iguanas feel heavy. These are kind of heavy-bodied things, and we want them to kind of, and so we'll look at some ways of doing that. Also, you're going to see that parts of them, there's crazy detail on iguanas. There's scale, 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 scale. And if you feel you have to draw all the scales, it gets really intimidating. So how can you simplify all that scale, 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 scale stuff? Get that in there. And there's one other detail that is really fun about these, and that is that some of them have these lovely wrinkly folds. And people who study figure drawing a lot often spend a lot of time with what they call drapery, which is sort of, how do the wrinkles form on somebody's shirt or blouse or pants or dress or a piece of cloth. We're going to be taking a look at a few of these ideas and applying those to wrinkly skin on our little iguanas. So we're going to have big blobby forms. We're going to have wrinkles on those. We're going to also have a suggestion of the scaly detail. And I think you're going to find that these critters are a lot of fun. Before I start, I want to send a mad shout out to the website birdpixel.com, where I got all the pictures of iguanas today. So is there more than birds at BirdPixel? Why, yes, there is. Master photographer Vivek Kenzode has curated this amazing site of photographs, and has also encouraged all of us in the nature journaling community to use these widely in order to help us with our drawings. So deep gratitude. And so if you're looking for some great photographs of these sorts of beasties to follow up on, or you want to spend a little bit more time with one of the photographs that you saw, all of those came from BirdPixel. Let's take a look. Oh, look at that. Hey, birds. Now, isn't this fun? I mean, the Galapagos are just crazy places. You'll have penguins next to marine iguanas, and then up on the bank there's a flamingo. And there's just so much stuff here. What you're seeing in that foreground there is a large adult and a little juvenile marine iguana. And we're going to, hold on, I'm going to change my cameras. There we are. There we are. So let's take a closer look at them. So this is the land iguana. This is the land iguana. And it's a delightful blobby creature. Really cool crest going up its back, large scales on its face, tiny little scales on its body, slightly larger on those legs. They like to crawl around on the rocks, and they nibble. They think that cactus are delicious, and so nom 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 nom. They're really good, and they're really cool critters. So let's take a look at this. Ooh, wrinkles. I wonder how we can draw those wrinkles. Well, I'm glad you asked. Let's just start off, though, with some basic body shape things. What I do when I'm drawing something like this is I often start with just the negative shape, kind of going up its head, down its neck, over its back, and then here it is, down its tail. So its back, And I can change this line. So there's a little sort of, I don't start with all the details. I start with just the general, the shape on the back of that. And then I'm going to kind of block into that some masses. So here's a little head shape. And I sort of think of this as chunks. There's then a neck chunk. And as I do this, you're going to see that I'm often sort of making my lines not, I didn't really do it here on the head, but you will see it a lot on the body and on these limbs. That what I'm trying to do is to get myself as I'm blocking something in, to kind of think about that as a three-dimensional form. And so that's why on this neck here, it's sort of curving around. In my head, I'm visualizing that as a little tube coming in. There's a body mass in here, and then there is thick tailness that goes off. It turns away from us here, and so then all of a sudden there's a little foreshortened bit at the end. It seems to like not get evenly small. That's because this part here that's facing away from us. And so that gives you that kind of weird little shape there. For my limbs in here, something that I find really helpful for placing limbs and things is it's really easy to start drawing the leg and kind of get this leg in there. But then sometimes the leg's relationship to the head doesn't really work. So something that's wonderful is the negative shape underneath the head of this beastie. So what I'm going to do is I'm going to look at, so the face comes in. I have mine too long, as I'm just saying. Face comes in, it comes down at about an angle like that, down a little bit more, and then there are these little feet. So if I put that space in, that negative space, it's going to help me get this limb placed correctly relative to the head. And I'm going to do the same thing between the front and the back legs. So actually, let me first put in a front leg here. If that's the shape that I'm seeing here in the front, then that's going to help me think of, I have a limb that is coming from someplace in here. And see how I'm thinking of that as a little tube sticking out. And that is connecting down to this little element here. And then we have our foot. And on the back, the leg has a hip, it has a knee, it has a heel and a foot. But here, this thigh part is facing towards us, so it's sort of foreshortened towards us. So that is I've got a cylinder that is coming out towards me here. Oh, I forgot to mention this. This negative shape here between these two limbs, priceless. That's going to help me not put this leg too close to this one. Generally speaking, oh, I already did put that leg too close to that one. Look at that. Yeah, if you just start drawing legs, this section of body in here is not very exciting to us. And what we'll tend to do is we'll tend to make it too small. Knowing that, let's actually move this back. Okay, that's feeling a little bit better. So what I did is I looked at the shape of the air here, and or the shape of the rock, and that's helping me be able to now. Let's kind of get this little the leg part that is coming out. There is a leg part that is coming down, and then there's our. Now I like to kind of look around on this. Like, notice on this one, there's much more leg sticking down here than I'm seeing on that critter there. Why is that? Well, oh, okay. So this shouldn't be coming down. All right, I'm going to take this and make this coming up over, and then my leg is going to come down here, and then my footness will be there. Okay, that looks a little bit better. So what I just did is I noticed a mistake. So you've noticed me making several mistakes, but as I'm rolling along here, I'm correcting those and not just getting locked into, oh, I made a little foot line coming down here. I'm going to stick with that. Now, really fun stuff. We're going to start to carve this. Your brain will tend to think of something like this as this flat surface. But if I start to put kind of contour lines wrapping around it, that helps me then sort of say, like, you know what, no, this thing, there's kind of there's a bit of a back here, and then the side comes down. Pencil. And what about here? That's kind of getting narrow. Oh, come down more. Okay. But I'm getting myself to think of this form then as a much more three-dimensional shape. Here on the neck, we're going to come out. We're going to wrap around the side of the neck, and then we're going to be tucking back in. On the head of something like this, initially I just had this little boxy thing sticking out here. Let's that's just a little bit of mention there. But check this out. So if we're drawing a head like this, I want to place eyes, I want to place noses, mouths in sort of the right places in relationship to each other. This thing's got its head turned towards me just a little bit. And so I'm going to do kind of a gesture sketch up here in its face to kind of help me be able to place some of my lines. Different people do these different ways. Here's what I often do. I often think that sort of the midline of my beastie's face is going to be here. And eyes are going to be coming across here at this angle, which means that the nose is going to be coming across here at this angle, which means the front of the lips is going to be coming across here at this angle. Those are parallel guides, and those help me kind of get my basic elements. If I'm going to have an eye somewhere in here, then the bump of the eye on the other side is going to be in line with that and parallel with that nose. Now, this is what I would typically do with my non-photo blue pencil. Then I would start to draw over this with a heavy graphite pencil or a pen, and that's what I'm going to do now. So I'm going to give this little one just a little bit of an eye. And some sleepy marks around its eye. The nose, the nostrils are really, really prominent. I can make this one a little bit larger. And on the other side is this little bump that sticks up. And here's my kind of lips. These guys have this wonderful, just very pleased with themselves smile, and so there's an expression that they have, and so to get that smile, I want to look at that smile is coming down below the eye, right? to a point somewhere in there. So if I put that dot in, it gives me a little bit of a target. And then I'm going to see that that comes down and then fairly straight. So down and straight. And then as it hits those lips, it's going to turn. There are really cool folds and wrinkles. I want to pay attention to sort of where these folds originate and then sort of where they're pinching off into. So if you notice across this whole area here, this part of the neck, there are folds that are coming in like that. They come down underneath the neck and they make the sort of these loose flaps. Studying a piece of cloth that you fold and wrinkle is a great way to practice folds. One thing to think about folds is that very often on a fold, there'll be one side of it that's on here. If there's a fold like this, there'll be one side of this fold that's a really, really crisp line. The other isn't. And so if, however, the kind of folds are sort of popping up like this, in some cases you do see both edges of the folds. But notice even on this one, there's this thing coming down here, clear edge. This side and here, if I drew a hard line in there, that would be visually confusing. But this far side, I'm going to get this. So what I'm going to do is my little buddy here has this great little dewlap that comes in. I'm going to put a little Y in here. And then here's the edge of my little fold. There's another fold that is coming around from this edge. Smaller ones here. So I'm making some little fold marks, which are kind of lighter, heavier. Like you can get these things to, you can taper these little lines. And if there's a little dewlap of skin that is folding over the other, what happens right here at the edge makes a big difference. I'm going to kind of make a little diagram here. Imagine that there's one piece of tissue, there's a fold coming around it. You often see that stick out as a little bump. If it's coming down as a ridge, you might see, I'm just going to draw in some little lines like that, suggesting that this is kind of pooching out here. If this is sort of hanging down in front, you're going to sort of see it go around here. Another thing that can happen though is you can get a fold that is going the other way. And here, notice with this one, I took this close edge and made it a strong line, but I didn't continue that all the way out there. That actually stopped before it got to that. Here is, so I can have this one this way. I could also have this little fold. Come around here, sort of make a hook around the corner. And then my fold of skin is going to come up. Where I could suggest that there's a ridge in there. At that point, this peeks out. And if there's shadows, there's going to be a little shadow down. So as this, as I'm kind of hooking these, draping these things around the neck here, I want to sort of think of how they're going to kind of fold around I want to look for places anytime a fold wraps around the corner of something. That's a good place to look for a fun shape. Another thing that happens in a lot of folds, you'll see that in here is there is, oops, hard to see all that. But I'm going to draw a little loop. Here. There's a little dewlappy skin. So they're sort of coming in from tension points out there. These guys will be taking a closer look at this. There are some wonderful kind of dragon-like ridges that these guys have on their backs. I can show that in here by suggesting there's a line of the body here that I'm going to make what it's called a hit-go-hit line. So it's going to come in light, right? Instead of so this little line, this edge is going to come and go. And then ridge above that. Put some wrinkles in this guy's face, kind of complete this smile, give it a little cheek. Far side of the head comes around, and then where the eye is, there's a bump that sticks out. Getting that bump is going to be really important for sort of making that far side of the head functionally work for you. This leg comes in, and just like a shirt sort of gathers in the armpits, we're getting cracks, wrinkles in the skin of this little beastie right in here. There are 5 toes in the front, 5 toes in the back. We'll be taking a look at the shape of those feet soon, but for now, just sort of be aware that very often these toes on the sides, these outer ones, will sometimes come out. You can have several toes going forward and then toes sticking out on the sides of that. You sort of see that here. You've got one toe that is here. I'm just going to put in a dark mark where that claw is and wrap a little bit of a box of foot around that, toe around that. More wrinkles. Actually, I want wrinkles coming. Yeah. Good. Line that comes off here. So if I want to suggest scales on this, from this distance, look at the thickness of my pencil. I'm drawing scales. Those are actually pretty big things. Those are larger than most of the things you're seeing here. Maybe I can show some of that along the edge of the lips. If I overdo that, it's going to overpower that shape of the mouth. There's a tendency to really draw in the edges of these scales with a little bit too much verve. So I'm going to be gentle with that. But you can sometimes suggest a little bit of scaling just by making a little grid like this. That suggests that there's some small scales in that area. So if I'm just writing here, a little hint that there are some little scale units. If I get in here and try to start going scale, 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 I'll get sick of going scales. So let's take a look at another. Here's one from a slightly different position. And what we want to initially get here, the critical thing is just to kind of get this pose. So take a look at it in terms of kind of big units of body. And I'm on mine, my head is going to come down, my body's going to go over, my body's going to wrap around, and then there's going to be some tail. I'm going to have a head over in here. I'm going to have a body, I mean a neck in here. This is pointing a little bit away from me, in the body. So I'm going to think of my tubes as going this way. Right? In here, there's a big kind of massive body. My first foot is going to be coming out in here because of this negative space. My next one is going to be fairly close to that. And so that helps me go like, okay, I've got, in here, I can see more of the thigh in here. Think of the back legs of these things as being slightly wider, coming to a knee. Sometimes there's sort of a flat knee. Then you're getting their thigh. Then you're getting down to the foot. Now we can't really see the foot here on this one, but we'll get to some back feet in this one. And it's going to help me also just to I'm going to keep my brain thinking of this thing as it's three-dimensional. This is kind of fun. A technique which a lot of artists like to use. Have you ever done one of those contour drawings where you just put your pencil down and you're looking at your paper? You're not looking back. Sorry, you're looking at the object, not looking at your paper. You can do what it's called a modified contour drawing to help you kind of get all sorts of nuances of things. So, for instance, up here behind the head, I'm going to just put my pencil down and there's kind of a scoop, and I'm now looking at my screen. There's a bump, and then there is another bump. Sort of point. So I can sometimes look at the kind of do a little bit of that sort of that contour drawing approach, and that will help me get things like this bump, and then there's second bump of the iris. I'm going to have an eye in here. Smile. I want to look at how far that is below the mouth. It just looks so pleased with the cactus. Like this leg. I want this leg to feel like it is coming towards me, and then coming down from there. So to get that effect and sort of the roundness of that, I want to pay attention to sort of this little point in here. Got a little bit of shoulder coming in there. The elbows coming towards me. I'm using a fairly blunt pencil with very dark lead in it. So it allows me to kind of, how do you get those really dark accents and lines? That's just because this is 2B lead in a 0.7 millimeter mechanical pencil. So I've got a fairly dull point, and that's a useful tool for fast sketching. Let's just take a look at one more pose. And what I want to do is to head, body, over. Oh, we're off the screen.
Thank you.
There's a great big body. There's a little bit of neck in there, and there's a head sticking out to the side. You've got a leg that comes down. You have a negative space, and then your other leg is just fluffed out here. The center line of this thing's back comes down and out onto the tail, and then you're seeing a little bit of the far side of the body on the other side. If I were to put a line, if I were to try to make this critter's back more geometrical, there is maybe the top of its back is like this, so that we're kind of coming out there to more of an inflection point, and then down on the sides. And what this, I mean, that profile of the head, that's so cool. There's that big bump, and then our spikes are starting to find that. I want to get that big bump in. I want to get that line of the face. Over, down. Where's your eye? Your eye is somewhere here. Sometimes if you give the eye just a little bit more attention, so look at this on this eye. I mean, most of this is going to be kind of handled lightly, but I'm just going to give this eye an upper lid and a lower lid. And then I am going to put some of these folds of skin right around that eye. That makes the whole drawing feel detailed. And my happy lizard face. And the older they get, the more outrageous the ornamentation is, especially up there on the back. And so you get ones with just that are just spectacular looking critters. Squint at this and decide for yourself what are some of the critical lines that you would want to get for it. For me, these little lines right around the eye that set that eye into place, that's really useful. I like this sort of this gentle smile of the mouth with a little bit of kind of a line by its cheek. That's its ear back there. And then some of these cracks there, those are just lovely. Look at that big spike there. So a little bit back behind there, you get into these, some of them have, different individuals have their own little spiky patterns. But sometimes there are some particularly dragon-worthy ones right in there. So again, when you're putting in wrinkles, notice where they originate from, where they are kind of going and getting concentrated into. You want to kind of sort of stretch them between those. Stretching that between there. Oh, so lovely. Now, the other kind of iguana is the marine iguana. And these guys have adapted to the oceans. They have a sort of a broad, sort of side-to-side tail. And by all the lava coastal rocks, these things are just colored just like lava. These marine iguanas will plop out. And oh, are they crazy, crazy, crazy fun. They are perhaps even cuter than the land iguanas. They have these dark skin, helps them once they've been swimming around in the water. Again, these guys cannot make their own body heat, helps them absorb heat from the sun to kind of warm up after they've been. Look at that dorso, that laterally flattened tail. Isn't that cool? Oh, right. And then what do? They crawl down to the water's edge where the waves are and nom 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 nom. Big claws so they don't get washed off. They eat the seaweed, the algae, off the edge, and others will go swimming and dive down several meters under the water and chew algae off of rocks. So their behavior is just absolutely fascinating. And giant, strong claws here on the feet that help them hold on, because if you don't want to be tossed around by the waves. Oh, look at this thing! But just the proportions of this thing are really, really weird. Really, really weird. Actually, let's bounce back there for a second. Let's all just make a. Let's make a quick marine iguana sketch. But we're going to do several in these several different poses. All right, my back comes here. My back has a lump. My tail goes long. Okay, I've got a body that's in there. I've got a little cone of a neck and a crazy short, blunt face. So these have a much blunter face than you get. Nice little negative space under the chin here that helps me place that first leg, and then negative shape here helps me place my back leg. So steep little cute face. I made mine too cute. Just really blunt. Okay, so we don't have these big skin flaps. So it's a little bit more streamlined. But look at this great little crest, this great little arc of spines. Sticking off there. big old belly. I want to think of the leg as the thigh, and then the calf coming down the foot. Just sort of dragging that through the sand. Didn't quite get the negative shape here underneath that. Okay. This is a very kind of typical pose where the legs, the back legs are splayed out. And the front legs are kind of doing this little push-up. So you'll see lots of lizards, from the little western fence lizard to marine iguanas doing that. So if I give you this head up, little head, here's a little neck, and my chest here is up. Back leg is flopped out here. This the calf here is foreshortened towards me. And then look at how big that back foot is. It's occupying all this space here. Parts of this that I would really want to dig into would be, oh, wow, look at that. Its face is so blunt, it's hard to make my face blunt enough. Look at how long and sort of weasel-faced I made mine. See that? So again, that's the power of, if you make a preliminary sketch, you can catch those mistakes before you commit to a pen line or a heavier pencil line. A lot of wrinkles coming in there. And one last sort of body gesture. This one is just splayed out. On this one, let's take a look at that top left-hand hand there. Notice 3 toes out in a row. And then there are little ones, the pinky and the thumb are more splayed out. So you'll often see 3 together, not always, we often see 3 together, and those ones on the side will tend to kind of go out more on their own. On the back foot, there is, so on the back foot, I'll draw this one's back foot from just sort of take a look at sort of the generic lizard back foot, which these guys do. Our little foot comes down and has a little heel. And then think of your foot coming out, and then the toes start happening. And this is so this is towards the inside of the body here. So this would be kind of what this foot might be doing. What you're going to see is 1, 2, 3, 4 toes that get progressively longer. The last one gets really, really long. So what that does is it makes a little wedge of toes with the first one, and then they get longer, and then they get longer, and then they're really, 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 really long. Your back, your toe on the other side is a medium length toe, and it is often out at an angle away from everybody else. So these ones usually you see them together, and but not all. So foot here, got a nail. Any practice that you put in drawing bird feet pays off. And this little one on the side. So you'll often see this basically shape. So 4 toes getting progressively longer than the outside one is just splayed out. So I'm just going to make up a toe. Like you can have all these toes here, and then you can have this outside one. It's kind of like something like that. They don't want to play with the others. This one, if it's one of its, it has 3 forward here. Sometimes you get another one that is off on the side. Look at these patterns. So if you're drawing the patterns on them, here this one is a little bit too far away to make that really convenient. Just remember that you want to visualize these bodies as some rounded form. So it helps just to kind of give yourself some contour lines before putting any spots on. Because then if I were putting spots and blotches, they would want to follow some of these same something coming up here. You know, so think of there'll be a change. So if there's a blotch on the side here, you're going to see that as a blotch. As you kind of get up in here, if there's a blotch of that same size and shape up in here, you're going to see that as that. So carve those bodies with those blotches. Similarly, if there's a blotch on a leg, you're going to suggest that roundness in the form. Oh, just love these little birds. You can't overdo the claws. I mean, just look at how disproportionate, if you had a head that size, how hard it would be to put in claws that are really that big. Also note this general thing, like here, you've got this dude really outside, these 3 in the middle together as a group. 3 together as a group, then these outer ones kind of doing their own thing. Here's this outer one doing its own thing. Here's an outer one doing its own thing. Let's make a sketch of this one just because It's really, really cool. So I don't know. It's not in the position I'm used to. So what am I gonna do on this guy? I'll show you what I would do, which doesn't mean it's the right thing to do. It's just sort of one way of approaching this. I would often start maybe with a sort of center line of the body and say, I've got a head here, and then I'm just going to think of this thing as shapes. All right, there's a neck shape that is attached to that. It's about the same size. The head comes down here, and the negative shape angle comes off like this. And so now I've got this little body. And then very often starting with negative shapes, that sort of that shape around the outside can really help form these things. Then, once I've got that, I can be like, okay, so then this much of this is this inside of this right here. And its foot is occupying this space. I'm just putting in a little placeholder for how much footness there is. Over on this side, I've got my negative shape says come down, my negative shape says come over, and then down again. Now I'm going to turn that into, here is this leg portion that is sticking towards me. And here is this leg portion. So then coming in. On the head, my mouth is going to be in here, looking rather serious. How much space between the mouth and the nose? About that much space. And then the eyes are very much on that line. And then I'm going to give myself a triangle in the forehead. You see, I'm just kind of looking for shapes, putting shapes next to shapes. Over here, I might consider this a triangle inside. A diamond on top. And before I kind of commit to drawing anything, it's good to sort of back up from it a little bit. Kind of like, ooh, you made this way too high. Okay, so that's going to be kind of somewhere in here. Nice that I saw that before I committed to it. So I'm going to just give it a dot for an eye, but I'm kind of going to elongate that into sort of this downward sloping eye kind of thing. Nostril. These guys, they're really fun when you are out there kind of sketching with them because they're constantly blowing salt snot out of their nose. They constantly are snorting out salt. So they've got these glands in their mouth to in their nose to get rid of salt. And so they're constantly just spewing that out their little noses. Putting some bumps here on the head. And to kind of complete this look, I'm going to put a little bit of a shadow in here under its lip, and then a little bit of a shadow underneath this dewlap here. Yeah, yeasty. Older one, look at what this one's got going on. Ah. Let's just try a blind contour. So put your pencil um, down under its throat, and without looking at your paper, just start. Imagine that your eye is a little ant that then crawls up and hits its chin. And slowly work your way up. This is not going to. Well, there's a look at those spikes above the far eye bump. The goal of this is not to get something that looks like the iguana, but just to really help your brain slow down and follow lines. Every time the shape in front of you changes direction, that's a decision point where you have to help your pencil change direction as the line changes its direction. You want your pencil stroke to also change when your eye is following something on a different angle. And there will be part of this that you look at it and like oh no, but there'll be little sections that are like yeah, that part, that's really speaking to me. This is such a great exercise to do. Like on mine, I look at it and you know my shapes are good, but they're too broad out this way. The purpose of this is not of an exercise like this is not to again to draw those, but just to help your brain make these decisions that come up, change angle here, change angle here, change angle here, change angle here, change angle here. It's a wonderful way also to start. If you're ever feeling stuck, just do a few of these little blind contours on things, and they will help you be able to handle whatever shapes you're looking at. And there we go. So in wrapping up, look at all the salt that this thing has blown out over its face. All that white stuff. It's done its salt snot thing. I wonder if this little lava lizard here is also getting some of that spray. Ah, that's really cool. So these are just wonderful, wonderful critters. And there's a group of us that are going to be going to the Galapagos later this summer, and we'll be sending back our sketches as we're here you go, as we're investigating. If you're not going to be there, you can do a ton from photographs. And something that's fun about drawing something like a marine iguana is that your brain doesn't really have this. You've got an idea of how a deer should look. So sometimes when you're drawing a deer, you end up drawing the deer in your head rather than the deer that you're seeing. But most of us don't have a real solid sense in our head of what a marine iguana should look like. And that gets us looking back at the iguana again and again and again and again. And play with it and see what marks you make. The more you practice this, the better it will get. If you ever start getting all judgy on yourself about the way that some lines are looking, just stop, breathe a little bit, and do some of those blind contours. The blind contours are great exercises that help us be able to draw what we see. And I hope that some of these strategies were useful to you. And I hope that someday you get a chance to plop yourself down on a beach and draw a Galapagos marine iguana from life. They don't care that you're there. They have been away from predators so long that it's like, that's fun. Thank you all. So what I'm going to do now is I'm going to stop this share and bounce back to my big screen. Let's first, I'd like to kind of go around and find out, does anybody have any questions, comments, or thoughts specifically about this Galapagos, about marine iguanas or marine iguana sketching, or issues that kind of came up from this Anne, I saw that you have got something for us. I'm going to add you into the spotlight here. Hey there. Oh, look at that. See, it's doing that great push-up. Did you take that photograph? Hold on. You can now unmute.
I was lucky enough to go to the Galapagos a long time ago, like 2008, I think, and took this photograph. And now that you mention it, I mean, look at those back claws.
Oh, I mean, they're so disproportionate. Like this crazy little blunt face, and then like all the effort that should have gone into giving it a nose has gone into putting those ridiculous feet on it. But it makes so much sense if you're going to have to if you don't want to get washed off a rock, you'd better have some good grabbers. And I also like the crest that this one has.
Yeah. And they're so easy to photograph and I assume to draw because they come out of the water so cold that they have to just sit still in the sun to warm up and get their body moving again. So they're almost paralyzed. They're just there like, oh, I can't move.
That was cold.
Yeah.
I'm cool.
Yeah.
I'm cool. You're cool. I'm cool. Well, cool. And also, may I just say that the textures on that log?
I know, that's my favorite part of the photograph. I mean, isn't that cool?
That is so cool.
It reflects something about the animal itself.
Oh, yeah. That's beautiful. That's beautiful.
And today's sketch is very fun.
Oh, hey, I like what you're doing with the simple shading on those. Really gives form. Oh, I love that. Were you using a blending tool or just your pencil software?
Yeah, I finally got a blending tool. So that yeah.
But let me actually. I'm going to minimize my screen so we can make that a little bit bigger. Oh yeah.
Yeah.
Doesn't that make you want to get a blending tool? But here's the thing that you have to do when you get it. You still have to use restraint. You have to that one on the far right. You see where there's that line of there's the shadow going up the side of the body, and then it stops, and you get the sense that there's sunlight hitting on that part of the body. It would be so incredibly tempting to, just because it was fun, to put use that blending tool to blend all the way up to that line, but then the form is ruined. So you have to kind of hold back from the brink of not blending everything. Part of the strength of what you have is the unblended zone. Oh, that's fun.
Thank you.
Hey, thank you, Anne. That's Anne Chadwick from Point Blue Conservation Science. Also, just want to say thank you so much for the work that you are doing on behalf of understanding and protecting species around the globe. Let me bounce over to gallery view here. Does anybody else have a something Galapagos marine iguana or land iguana related from thoughts or ideas about today's class? and then not seeing that, let's see what's just happening in people's journals. If you have if you've been out doing some observation and sketching and journaling, I'd love to see what is happening in your journal. So you can use the raise hand function, or you can hold your journal up to the screen, and I'll see that. Let's start with Walters. You can now unmute, and there you are. Hey, good to see you.
Hi. I wanted to say thanks. I received the pages, for underwater drawings.
Oh, okay.
Yeah. The problem is I'm here only for a week now, but maybe I still will get a chance to try those out. But I wanted to show you. I have it on my iPad here, but I'm going to show it through my phone. For a school project in biology, I had to make an infographic about.
Oh, that's a great exercise.
Yeah, I had to make an infographic about parasites, the parasites that are on people, or not on, but and I chose to make one about ticks. You have them, right? Ticks, yes. And there had to be included a photograph or a drawing, so I thought I'm just gonna spend some time and learn some digital drawing, because to draw it on the paper, it would be hard to match the color of the paper with the infographics color, and so I did it in Procreate digitally, and I'm happy. I'm happy how it turned out. So this is
look at this. This is really cool.
It was hard at the beginning, because once you put down only the colors, it looks very plain, and so I figured out once I put the highlights in, and you can see little hairs here.
Oh, that's cool. All those little joints are so cool. All those little sections on that. This is so ticky. Oh, that's really fun.
So it was fun to do, and I can I wrote my signature, so it's my own drawing for my own infographic. So
that's fantastic.
It was cool to do, and it was fun also to try digital, to learn a couple of new things. So
yeah, and so good. I actually have been at some point. I'm going to get an iPad that is smart, or tablet that is smart enough to use Procreate. I've heard very, very good things about that that software. Sometimes the software that you use to try to do illustrations and things on computers is just so clunky that it kind of gets in the way of your drawing experience. But my understanding is that the user interface is out of the way enough and intuitive enough that that you can really start creating like a pro.
Yeah, and I can recommend, if you also are learning Spanish, yo también aprendo español, but you can go. You know what Domestika is? That's a special site where people put up courses. Well, not people, but different creators and teachers. It's an app called Domestika, and they put up courses, and there is a course in Spanish. But for drawing, illustrating animals, birds, and insects for Procreate, and you can get it for like $20, and there's lessons, and he explains, and so if you ever get into that, it's worth watching. Yeah.
And also, what a great motivation to get better at your Spanish.
It is. Right? It is. Yeah. And one more thing was, now we are sort of remodeling our apartment, and I thought about putting up some drawings, and since there are a lot of Corey's shearwater is now returning to the ocean close by. I did a couple of studies to put up.
Oh, that's cool.
So also,
oh! Look at the wing angle on that one. I love it.
this one?
Yeah. That most people who are, if you haven't been sort of studying what foreshortened bird wings do and can do, you look at that and go like, wait, you didn't draw part of the wing, but that is exactly what they could do when that wingtip starts coming towards you. But it's so hard to draw that view because your brain will fight against what you're actually seeing. You're like, no, I could not be seeing this. I could not be seeing this. This just isn't right.
When you start drawing it, it doesn't look right at all. Once you finish the drawing, it looks like it should be. But once you have to put in actually the line, that's not it. That's not it. So, but yeah, we'll put these up. So.
Oh, that's cool. That is really cool. Thank you so much for sharing that, Walters.
Hopefully, I will get to try the paper. So
I hope you get a chance to mess with that. Sorry, I didn't get that out to you earlier, but no, I'm glad it did arrive. It's on a very slow boat coming over to you.
It's on a slow boat.
By the way, for folks, what we're talking about is Walters has been is looking at techniques for drawing underwater, and so can you describe your approach and technique?
Well, for now, I don't have it here, but for now, I've been not while scuba diving, but mostly now by snorkeling. I've been having this special sort of a plate that has a graphite pencil, and when I see a fish or other critter that interests me, I make a quick sketch of it, take some notes underwater, and then when I come home, I do a more refined sketch in my journal. Mm-hmm. So, but it's a easy way, so you don't have to look at photos after the dive. You can have already your sketch, and the proportions and the angles are all there. So it's fun to do. It's fun to do.
That's great. And so what I sent Walters was a few sheets of a packet of Duraline paper. And this is essentially, it's a plastic drafting film that you can bring into salt water and then draw underwater with your pencil. And it feels like paper when you're drawing on it. It's a good drawing service. A lot of illustrators will use that. If you don't use it for that, another thing you can do is anytime you have to trace something, you put that piece of Duraline on it. You can see through the Duraline.
Yep.
And so it's great for doing a tracing. And if you then ink that, so you do an ink drawing on it, you can then let the ink dry and then take an X-Acto knife, a sharp knife, and you can scratch away parts of the ink off of it, and it sort of gives you a scratch board like effect, and it looks really cool.
Okay, we'll try it.
So if you don't end up using that for underwater, you can get all terrestrial with it, and that's fine. Oh, and one other thing that some people will sometimes do with it is that they will actually put color on both sides of it. Sometimes an initial coat of color on one side of it, and then put details on the other side of it, and so that color comes through a little bit, sort of as a base coat of color. You can mess around with that.
Base coat.
Yeah.
Okay.
So.
Okay, we'll try it out if I don't get a chance to try it out underwater. So thank you, Jack.
Absolutely. Good to see you.
Good to see you too.
Let's join our friend Ray Bonto. Hey there. Good to see you. Hold a second. You can now unmute.
Yeah, good to see you too. So, well, I had to do a lot of pages because a lot of attention went into the sketches, so I had to make them big.
Yes. I love your line weight on those. That look at that one on the bottom there. Also, I'm seeing. Oh, were you intentionally doing snodgrassing, or did you reinvent snodgrassing there? Have we talked about snodgrassing
In your book?
in the book? So, were you intentionally doing that, or that take a look at that place where there's that little Y-shaped fold on that bottom one there. You see that little kind of extra bit of darkness where those lines come together. Kind of gives you this sense of sort of a deeper dark right in there. Oh,
I don't know that.
I like that. I like that a lot.
And then, oopsie, I get upside down really easily, but
Oh, nice work. Again, your line variation is really strong. And also notice that, but because the line on the underside of the body is the heavy one, and that one on the back is lighter, you get a sense of actually there's a shadow underneath this thing just by that line variation. Now imagine the same drawing with how tempting it would be, because it's satisfying to draw that line in around those, the legs and on the bottom there. That's fun to do. How tempting it would be to do that all the way around the thing. And then it's not going to feel as dimensional, because with that lighter line on the top, that just sort of, that lets a little bit of light through, that really kind of helps this thing. It helps it helps us see the form, having just the dark on the bottom. Oh, yep. You're really thinking about those leg forms three-dimensionally and how they overlap, how they play with each other. That one, you can really feel it splayed out on the ground.
I made a quick one of the feeding. And
yep. Oh, that nice sort of walking stance one. Yep. Oh, I like this guy.
He's a blind.
Yep. Yep. Yeah. What in a drawing like that, it's part of it is what you put in, and part of it's what you don't put in. I also love the rocks covered with all the little marine iguanas. Also one of my favorite little gesture lines here is that one on the top there. Look at that, just sort of that simple blocky face, shape of the head, line at the back, and boom, you've got your iguana. Love it.
Last one.
Yeah. You even had time to drop your watercolor in on them.
No. Molly recommends this. It's a water brush filled with ink.
Oh, that's
You
really
just
cool.
open it and splash. But it tends to fade, and then you need to put it on again. But it's still quite nice.
I like that. I really like the head shapes, the eye placement. And it's also clear that you're thinking of that body as a rounded form. It's not a flat surface.
As for my nature journal, I only got to do one thing since Tuesday, because yesterday we had a thunderstorm.
Oh.
And we were outside, so I couldn't have nature journal that. So today, it was super windy and documents were flying all around me. And my book was flying, so I couldn't do a lot.
Ooh. Oh, nice work on those petal. You really understand the way that petals, the foreshortening on a pointed petal that is seen at an angle. That is such a difficult thing to do. There's some real subtleties in there that you grasp. Wonderful.
Thank you.
Ray Bonto, again, we are just delighted with the work that you're doing. Putting in all those pencil miles and continuing to work and develop this skill, you're going to have no idea about the way that this skill is going to open up doors for you, just in the way that you think and the way that you encounter the world. Really delighted with how you are seeing and the development of your work. Well done.
Thank you.
That was inspiring. Let's see. Susan, hey there. Folks should know that Susan and I, behind the scenes, are starting to hatch some wicked plans about measuring the diameter of the planet.
Hi. Yeah. Yeah, we've been emailing a bit, and I think that my earlier claim on Tuesday that we could use any 2 points on the Earth's surface at the same moment in time, I think it turns out to have been wildly overambitious. Thinking about the geometry more, but yeah, but it's quite a question.
But also, can I say just how much fun it is to be in something where we've got ideas,
Yeah.
and then we are. So when they hatch in your head, it feels right, right? And then you put it down on paper and you start looking at it, and then that's when your brain starts to go like, wait a minute, the getting it out of here and onto paper is such an interesting part of the thinking process.
And sometimes you're really very sure that you're picturing it right, and it's only when you're unable to put it on paper that you realize that you actually were quite wrong and you need to figure out a way. And sometimes, as we experienced, I think a few weeks ago when you were measuring the positions of the sun and moon throughout the day and night, close to the spring equinox, and we were discussing this, and I made the claim, after drawing some very nice diagrams that were very lovely and very understandable, I claimed that the difference between the maximum angle of elevation of the sun that you observed and the maximum angle of elevation of the moon that you observed, which in that instance it was lower, that difference should be approximately equal to whatever is the tilt of the orbital plane of the moon. Right?
And that made total sense to me.
Yeah, and I had a great diagram. Unfortunately, I cannot find that diagram right now. I need to do it in a book where I can keep track of things. But, and you said on Tuesday that you went and you looked at those measurements that you'd taken and determined that rather than being that difference in angle of elevations, rather than being about 5 degrees, which is the actual tilt of the angle of elevation of the moon, tilt of the orbital plane of the moon relative to the ecliptic, that difference was about 30 degrees.
Yeah, actually, let me. My journal is in on the couch. I'm going to go grab it so that was it 30 or 20? It was big.
Yeah. So on Tuesday you said you couldn't remember if it was 30 or 20, but either way, I think it's still. think it still works. So trying to define our terms here. Yeah.
All right.
So either way, that difference was wildly different than what I predicted. And that was so exciting because like the best thing is when you figure out you were wrong, it leads you to new things to figure out. And I've got more diagrams for you, and I don't know if those ones are right or not, but we'll see.
So yeah, let me take you over to my little data set, and it was 30.
Okay.
So, oops, that's not what I wanted to show. I wanted to show this. Oops, I'm frozen.
Oh no, you're frozen.
I wanted to show. I guess I don't want to show that.
Actually have some not cloudy days for
Let me
once.
try this one more time. I want to show this camera. Nope. Not going to happen. I'm just going to hold it up to the screen. Do it the old-fashioned way. I don't know why. It's not working. But,
what a nice intersection of planes there.
Why, thank you. I had fun doing that.
Yeah, I've been there's something I'll show one at a time here, but I've been if I picked a heavier paper that I could have gotten more color on. Anyway,
but there's a huge difference in the height of the sun and the height of the moon.
What did you get
and that
for
is,
the highest
that is well outside of my margin of error.
Yeah, because you're just measuring by like a goniometer or something. You're not just doing this kind of thing. You've got
no. What I was doing is I had a compass.
Okay.
And the compass has a little an inclinometer on it, and so I could point the compass at the moon and line the compass up so that the compass was in line with the moon, and then in a little mirror read what the inclinometer was.
Okay, yeah.
And to get the sun, what I was
Presumably
doing.
you were facing south. At different times of the night, you're facing different directions, but you were facing, I presume, due south at that when the moon was at its highest point, right?
Yeah. It was at its highest point. Yes, when it was in the southern sky, but that was only about 25 degrees up in the air. Whereas it was about the sun had gone up to about 55 degrees.
Okay.
And so for measuring the sun, I was using my inclinometer, but not looking up at the sun. I was looking down at the shadow of my head. And
okay.
That the angle from my head shadow through my head would be the same as the angle from my head to the sun.
Yes. Assuming yes. I was going to say, assuming you're standing up tall, straight, but I guess we already determined that, in fact, because you have something that's using a plumb bob, it doesn't actually matter if you personally are standing up straight. Yeah, but okay. So the thing is, I had originally claimed that the difference in those maximum heights should be about 5 degrees. Should be about the same as the angle of the moon's orbital plane. Right?
Yeah. So when
the
I looked
actual
at,
difference,
I then went to thinking that I had it solved. I went to NASA's website and said, "All right, let's just go for an independent confirmation of it. What's the difference in the angle?" This was about 5 degrees. And I was like, well, first I was like, oh no, but then I'm like, oh goody, because that means that
that means you have something to learn.
Yeah, exactly.
So, right. So that means that the difference between our claim, I'm saying our claim because you're complicit in getting it wrong just as much as I am.
I'll take that.
Good. So the difference between our predicted value and the actual value of that angle of the moon's orbit was about 25, right?
Roger that.
Do you know what other important angle in the solar system is about 25?
I'm guessing the angle of the ecliptic angle relative to our orbit.
Yeah, so axial tilt, right? Which is closer to 23 degrees, but really I would say that's well within a reasonable margin of error, right?
Yes, yeah, that would be subsumed by my margin.
Do you know what else happened between the moment that you measured the sun at its highest point and the different moment in time that you measured the moon at its highest point?
So yeah, those were at very different times.
Yes, in fact,
it
the moon was
was
at half moon, so it was probably about
1:30 because we're daylight savings time. About 1:30 in the day for my highest point, and at about 6:30 at night.
I would have guessed 7:30, but that's good. We're also, I mean, it's also, you weren't necessarily out at the exact moment every single time anyway. So I would say that's still with it. The point is that the Earth made about a 1/4 rotation. And what that means is, since this was very close to the spring equinox, that makes things a little bit simpler. So here, this is the same caveat as the previous discussion here is that I started making a diagram and then I started adding things to the diagram, and it all was making sense as I was adding it, but I don't know if the finished diagram is going to make sense now because there's so much stuff on it. But we'll find out.
Yeah. So we're not making any claims for being right, but we might be kind
right.
of internally consistent.
Right. So I guess the thing to do now is to take this model of the solar system, or the Earth, Moon, and Sun system, and make more predictions, and then see if those predictions come out right. So what's happening? So first of all, and this is like a very good thing to do. Simplify the situation you're discussing so that you can understand it better. So doing this on the equinox was the best possible day to do this. Being close to the equinox gives you a little bit of error, but probably not. You're only a few days off, so not very much, right? And doing this on the half moon also helps. That's, you know, if it were a few days earlier or later, that would be more difficult to work out, right? And considering these things at the moment when the moon or the sun are at their relative highest points in the sky, rather than at other times of the day, makes things easier. And the problem is that what I forgot is that it actually matters that those are at different times of the day. So because you're at the equinox, the Earth, and I'm conceding to now use a heliocentric model because I think it actually does make it easier to understand in this case. but I think so. Your Earth has the axial tilt here, but because we're on the equinox, that axial tilt is not pointing at all toward or away from the sun. Like, it's not pointing this way at all or that way at all.
Yeah,
it's pointing in a direction that's basically perpendicular to the line between the Earth and Sun. And that helps things considerably. The moon, meanwhile, is basically 1/4 of an orbit away from that line because it's a half moon. I think I remember you saying it was a waxing half. It took me a while to figure out which side it was on, but it probably doesn't matter that much for purposes of this, but I did have to make a correction there. Little key there for which heavenly bodies are which. Okay, so if we want to know where is the sun at its highest point in the sky, or how high is that point on this day, then we should look at a direction that's basically perpendicular to the line between the Earth and Sun, so that we can see the sun over here and the Earth. As we've established, all lines parallel to these lines are all pointing toward the sun. So we can look at that. I don't know if you can see them, right? And as also established, this angle between the, so very, very important here is that the sun is shining directly overhead on the equator because it is the equinox. if it were not the equinox, the sun would appear to be slightly above or below the equator, or would appear at a certain angle. As viewed from the equator. So it makes things simpler if we're on the equator. And what happens is you figure it out for the simple version, and then you figure out how it changes for the less simple version, which I still don't know yet. Okay. So we established last time that your latitude is the same as the angle between basically the equator and the center of the Earth and where you are.
That was really fun because I've never thought about latitude that way.
We think of it as just lines on the globe, right?
Lines on the globe, but not
right.
projected from the interior of the sphere.
Right. So if you take this line here and you sort of rotate it all the way around the globe, you make a sort of a cone shape inside the globe, and where that cone intersects is a circle that goes around the globe at a certain latitude.
Yes.
Yeah. Okay. So, and this is correct. I'm very confident of this particular part of the process here. Okay. So the angle of elevation, the horizon is basically a plane that's tangent to the globe, and you looking straight up is perpendicular to that. So your angle of elevation is measured from the horizon up to the direction of the sun, which means looking straight up. This is what you're seeing if you're standing there. Looking directly up is 90 degrees. The sun was never directly overhead, so you never got as high as that point.
That's right.
Okay, what I drew in the pink angle here is this angle of elevation you measure, and what you're drawing is just showing all these sort of, the path of the sun making some sort of arc, kind of like that, right? And your latitude at San Mateo, California, about 38 degrees. So this distance should be the complement of that 90 degrees minus that latitude, which is about 52. You've got 55. I would say that that's well within like a reasonable margin of error for the process that you're following, and for the fact that it was a few days later and all those things.
Oh, wait. So
actually, now I think about it, because it was after the spring equinox, the sun should be slightly higher in the sky, and so you should get a number slightly higher than this, as you did.
Oh, wait. So if you are looking at the height of the sun on the equinox, that at the highest point, that is giving you your latitude?
Well, your latitude is going to be the difference between that height and straight up. And when we're saying height, we're meaning
yes, that makes sense. Because if you're at the equator, it is straight up. It's at 90 degrees.
Yeah, and the higher the sun is, and that's why the closer you are to the equator, the higher the sun could be in the sky, depending on the time of year. Because this thing will be smaller. Your latitude will be 0 on the equator.
That's cool. I think I'm going to need to doodle that, because that's beautiful. And I also like, I'm looking down at your little drawing, the connection between your drawing
and the
left.
This part I'm very confident in. I tried to sort of like establish, like, this is what we're looking at from outside the solar system. We're looking in this direction at the sun and Earth, and by the way, also at the moon, which is slightly below there because of the angle of its orbit. And does this count as a zoom in, zoom out, or a start zoomed very out and then zoom in more and more and more? I guess. I hope it didn't turn into so many details that it's impossible to understand. The next one is more complicated, but that's okay.
That's really cool. And also, so folks notice that Susan has color coded this for us. The angle in red there, take a look at that. That's the angle then between where you see the direction that you see the sun and your horizon. And then to straight above you is that little blue line. And then look at how that kind of matches over there.
I
Oh,
also
that's cool.
noted. So noon-ish, but in fact, this is made more complicated by two things. One is that at different parts of your time zone, you are different distances east or west, which means
Yeah,
that
that's right.
And then it's also daylight savings time. So it's basically it's midday, but the specific time is going to depend on exactly where you are.
Oh, this is fun. So I'm following this so far, but I still do not. But this is for me is not explaining that extra how the extra 25 degrees jumps into the equation.
Right. So the problem is if you want to understand the angle of elevation of the moon at its highest point. So to look at the sun, you're basically standing on the Earth. You're standing on the part of the Earth that is sort of facing away from us in this picture because it's facing toward the sun. And we can see you because we in my diagram are looking at things this way, and that's why we can see you standing right there. 6-ish hours later is when the moon is highest in the sky, and that's specifically because it's the half moon. Actually, now I think it's actually 6-ish hours earlier because it's the waxing half moon. That's why it was in the morning. Right, so you said it was about 6:30, which seems like it should be 6 hours earlier than this, which would be 7:30, wouldn't it? But so I don't quite know why the numbers are a little off there, but it's close enough to hopefully tell us something. So the difference is in order for us from the outside of the solar system to be able to view this, I have us looking from basically sort of like from the other side through the sun to these two. We're looking at this from a right angle relative to what this diagram is. And that's why, see here in this diagram, right? There is axial tilt, but if you're viewing it from this angle, you're not seeing the axial tilt. The axial tilt is basically tilted like this. Well, right? The axis is tilted like this. And you're not actually seeing it in this diagram.
Nice
When
use,
you look
by
at
the way,
it,
of the cone arrow.
Thank
to
you. Well,
show
thank you.
Axial tilt.
Learn my lessons. If you're having to look at it from a different angle in order to see the moon, you can see the moon in here, by the way, but you can't really tell anything about it. You have to look at it from an angle. And now all of a sudden you do see the axial tilt. And this is where I said there's lots of angles, it gets very complicated. So I don't know, because I started having to add angles, and then I was like, oh, maybe I should color code them, but now there's so many colors, so I don't know if this is actually understandable or not. But because we are having to look at this whole system from a different orientation, now we are actually seeing the Earth's full axial tilt. It's actually tilted along this plane of my paper in this direction. And that's why we're seeing it. So here is the ecliptic. Because I happen to have us looking from across the solar system, that's why the sun sort of appears right in the middle. Don't, in fact, do that because you will not be able to see the Earth because the sun will be in your face. But, so I put the sun in just so you see, but it honestly doesn't really help the explanation, right? And then now there's a bunch of angles you have to figure out. So basically, the green line is the equator, which is 23 degrees off from the ecliptic. That blue angle there is still your latitude, which is still about, 38 degrees. So not to scale, but so there. And then in this case, the plane that the moon orbits the Earth does not quite go around the equator, and it does not quite stay in the ecliptic. It's about 5 degrees off from the ecliptic, and in this case, it happens to have been tilted sort of the other way relative to which way the Earth is tilted. So this, in my drawing, looks almost like a right angle. It's really not. It has the potential to be a right angle or even more than a right angle, but in this case, I think that's a little extreme. And it's hard to see, it's hard to tell, but that angle there is the sum of these three things: your latitude, the Earth's axial tilt, and the tilt of the moon's orbital plane add up to this orange angle. And then when you're measuring the angle of elevation, that's how high the moon is above the horizon. So that's the purple angle. And then here's the picture here. So you're seeing the purple angle is the thing you're actually measuring, moon's angle of elevation. And the orange is all that other stuff. It's the your latitude plus axial tilt plus the moon's orbital plane angle. And then if we take 90 degrees minus that, we get 25 degrees, which is what you measured. Which is quite a relief to me. But it
Holy smoke!
You're wrong. So and so therefore the difference.
Wait, hold that up one more time. Wow. It's going to take me a while to just to start trying to digest this.
Yeah, I'll have to scan this since I'm not on Facebook. Otherwise, I would put this on Facebook. But I would scan it and happily send it to you or anyone else who's interested. And so I think so. Basically, the thing that we didn't take into account the last time we discussed this is the fact that the Earth has rotated a quarter of a turn, and therefore the axial tilt of the Earth didn't make a difference in one instance. It does make a difference in the other instance. And if we did this on a different day, then all of that stuff would be slightly more complicated because these things wouldn't all be quite aligned in quite the same way. So
would it be
as far as I know, it's just a coincidence that you have a quarter moon on the equinox or close to.
Would the moon be on the solstices then be
solstice
5 degrees
over here
off of this, and on the other equinox be then 10 degrees I think I need to go grab some Play-Doh. And
I was thinking get some styrofoam balls from the craft store and cut them in half and start making some diagrams.
Yeah. This is beautiful geeking
I have a
out.
feeling on the solstices, you're going to find that the difference between these two measurements goes back to 5 degrees. The way that we predicted.
That I think we need to.
Here's the thing that I'm not sure. Isn't it sort of like weirdly convenient? Weirdly convenient is a term I've just made up for like that seems like we shouldn't assume this. Isn't it weirdly convenient that the tilt of the moon's orbital plane kind of is like sort of aligned in this way so that tilt is at its most significant for us when we're on the equinox? And of course, what you were measuring was even a couple days after the equinox, so it wasn't the same. So I started speculating on this, and I'm thinking, okay, there's these 3 planes that we're talking about. We have the plane of the ecliptic, which is the plane through which the Earth's orbit around the sun is. Or from the Earth, it's basically the plane that of the sun's orbit around the Earth. We have the plane of the Earth's equator, and we have the plane of the moon's orbit. And also because the moon actually has an axial tilt as well, there's a secret 4th plane, but I'm not getting into that. So there's those 3 planes, right? And all the diagram that I was just showing you is relying on the idea that those three planes are aligned in such a way that there's a common line that they all pass through, which is at least on the day of the on the day of the eclipse, sorry, on the day of the equinox, that line is the line between the Earth and the Sun. And if we assume, the Earth's axial tilt kind of stays in the same configuration as the Earth goes around the Sun, and the plane of the Moon's orbit, we are assuming, is also staying in that same configuration. But isn't that weirdly convenient?
Yes.
A more general situation.
And you're just pointing out that may be an assumption that we shouldn't be making. Exactly. And then I love also your other little diagram here of the different ways that those three planes can interact.
Right. So like a more general situation would be they meet like the walls of a box, maybe not quite at right angles, of course, but whatever the line of intersection is between the first two planes, the third one may not share that same line.
Yes.
Right? Now, it's possible that you could have three planes that don't even have a common intersection at all.
Mm-hmm. Mm-hmm.
But these three planes all have one thing in common. The Earth's center passes through all of them, I think. So, therefore, it can't be these sorts of configurations. But so this is okay. So this is the question. I think that this is like kind of key to your question you asked about: are we going to get like this a certain angle that's predictable on the solstices or on the next equinox and so on? The question is, as the Earth is going around the Sun, and we can consider the axial tilt of the Earth. That is the amount that the Earth is like tilted in its rotation. Of that sort of has this like fixed orientation as the Earth goes around the Sun, and we study that, and that's how we understand how we get the seasons and things like that, right? Of course, that actually has a wobble as well, and that's I guess we can sort of like use a frame of reference for which that is fixed, right? But if you think of that as being fixed, the plane of the Moon's orbit, is that always in the same orientation relative to the axial tilt and the ecliptic, or does that plane sort of rotate around basically over time and go in different directions over time? Because I think it might. And if it does, then it's just a coincidence that it happens to be oriented in a very convenient way on this particular day or around this time that you were measuring this. And if we wait a year or half a year or 6 months, it may have an orientation that's something totally different, and we may have different results that are like something related to, that we could sort of figure out how they change from these, but might be different. And I don't know.
But what we could do then is we could make a set of predictions of what we would expect to see if they all intersect along the same axis, and if they don't. And then we could look to see whether that prediction comes. And so we could, without Googling it, old school, be able to figure out what the intersection diagram looks like.
Yeah. And this is, I think definitely doing it when things are when like certain things are at right angles makes it easier and perhaps makes it possible to like make sense of without having to get really deep into like vector calculus and that. I mean, not that I mean, people have been doing this since ancient times without having vector calculus as we do now. So it's not as if it can't be done. But it's definitely easier to figure out when things are at right angles. So that would mean on the equinoxes, on the solstices, also in the full or new moon phases or the half moon phases. But those may not align because we may not have a full or half or new moon on the solstice.
On or very close to.
Right. Now, I guess, being that there's a week between any of those phases, you could probably just like pick the day that the moon is full or half or new that is closest to the solstice, and you'd only be off by a few days as far as being off by a few days in the moon's orbit.
That's a big deal.
Significantly change things.
But
being
in the
off by a few days in the sun's
365,
orbit is probably not going to change things enough to compensate for whatever margin of error in our measurements.
that's right. That makes sense to me. That makes a
Did I
lot of
just say
sense.
sun's orbit? I meant Earth's orbit around the sun. I'm still, geocentrism is hard to shake. So, yeah, I don't know. So maybe there needs to be, a solstice sun-moon party, and we'll figure out what phase the moon is going to be in near that, and pick a day near the solstice.
Can we also have a perihelion and aphelion party, please?
Yes, but can you remember what that is? I mean, I don't know why I'm saying yes, Jack. It's your. Oh, that's when you're nearest and farthest from the sun. Yes. See, here's the question, right? Like, does that line up with the with the seasons and the solstices or the equinoxes, or does it not? Or is it close but not exactly? Because there's no particular reason why the tilt of the Earth should be totally lined up with those, extreme points on the elliptic orbit, right? Like, why should we assume that that's the case?
And then we can throw into that the moon is also doing in an elliptical orbit around the Earth,
The moon has an
and
axial
so
tilt.
it's sometimes closer, sometimes further away, which is why we sometimes get a total solar eclipse and sometimes an annular.
Mhm.
I think that what we need to do is have lunch. We also need to have a party. So tell us your thinking here. Yeah. Yes.
Yeah, I can't quite see.
I didn't understand very much of what y'all were saying. I was trying to, but
Sorry, I was trying to not get too. I tend to talk fast when I get excited.
but just ideas of some of our questions.
Oh, you're showing the moon's axial tilt as well as the sun's as well as the Earth's axial tilt.
Yep.
Yeah.
And also questioning what the angle is of the moon to the Earth.
So I'll be honest with you. I don't think that I realized that the moon had an axial tilt to its
I'm guessing.
rotation.
More like I don't want to
recently.
assume. It's more like I don't want to assume that it doesn't.
Yeah, I think I was just assuming that
I
it
like
didn't.
that thinking.
But now I'm realizing, because here's the thing. So Jack, months ago when you were introducing this international moon, it was very shortly after I started coming to these, and you gave a whole presentation about the moon, and you were showing this fact that the moon kind of shows ever so slightly different faces of itself. And
Yeah, it does. So it does this
might
sort of
be
a thing.
because of the axial tilt. So it's, even though its rotation is synchronized with its orbit, it's still is that essentially effectively the equivalent of seasons on the moon? Maybe, if the Earth is the sun, the moon is the Earth. But I don't know. Or is there another reason why that's
No, I think that,
because I had not actually made that connection.
It is making a full rotation once, I think, about every 27 days, a little bit less than a month.
Mhm.
So
Same as it's making a full revolution.
yes.
Well, actually, no.
Because,
That's not the same.
so yes, as it goes around, it makes a full rotation. And
Technically, I think it has to make slightly more than a full rotation as it makes one full revolution.
Isn't it sort of like, we'll pretend that you all are the sun, and then here is our Earth that just spins. So even though the Earth is also doing this, right now the Earth is looking at you, and then it spins and it takes a full day to look at you again, But meanwhile, the moon being tidally locked, is it that the moon is really following the Earth, or is it that the moon is holding slower while the Earth, okay, I can't really do this with two hands, so we're just going to pretend that this is actually going this way, but whatever, that the Earth goes like this, and the moon, and the Earth goes quicker, but the moon goes a lot slower. Could that be part of it?
I think the
Maybe, or is it faster? I don't know.
right, Kadama is the moon,
Mm-hmm.
right? As it takes the moon about 1 month to go all the way around. But Kadama's face is actually, I'm going to turn it this way so that you see Kadama's face here. That the same surface of the moon,
Mm-hmm.
if you are the sun, my head is the earth, this is the moon,
Okay.
right? So if you're sitting, as I'm looking at here, I'm constantly seeing Kadama's ear,
Mm-hmm.
all right?
So we're
And you're
seeing different
seeing,
parts.
right.
Right.
And you're seeing these different views. So Kadama has actually made a full rotation, right? Each
And
time it goes
one-
around.
Yeah.
But
yeah.
from my perspective on the Earth, I am seeing the same view. I'm just seeing Kadama's ear the whole time.
Okay.
But Kadama has actually made, oh, hey.
So what if Marionette here? What if Marionette's the moon? And okay, this is going to be so challenging. Okay, so what if
That wants to join in?
so Marionette always faces the Earth at a certain place, but what if Marionette takes longer to move? So the Earth is meanwhile moving a lot faster in the sun's eyes, but then the moon is moving a lot slower, but still always facing the Earth. So the Earth is going woo 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 in the face of the sun, and then meanwhile woo 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 woo. I can't shake it too fast because this is going to just splatter everything everywhere, and it's going to be a mess. And I don't have
You're right. So that my head should be spinning around like Exorcist.
exactly. Thank you.
As I'm going around here.
Yeah. But Kadama's taking their time.
And your head is spinning a lot faster than the moon.
Yes.
Yeah. Kadama's moving slower, Earth is spinning a lot faster, but Kadama's always facing the Earth in its slow dance.
So I realized why I was thinking it should be slightly more than one revolution is because if you're comparing the the lunar day, the time it takes the moon to rotate one direction all the way around, right? Which is the same time that it takes the moon to make one revolution around the Earth. But that is slightly slower than one, I'm going to say month, but basically than the time between we see one full moon to the next. Because in the meantime, the Earth has traveled a little bit, about 1/12 of its orbit around the sun, which means after you finish, if I'm the Earth, right? This, right? But in the time it took me to do that, I've also moved over here, and I'm turning a slightly different direction in order to be facing the sun.
Ah. Yeah.
Right? There's actually
more I hear you.
revolution in the time between one full moon and the next, which is
You're 1/365th in a
no, I'm 27 365ths
per day.
or more.
Each day you move.
Oh yeah.
Right, you move a degree.
Mm-hmm.
We've been holding it wrong. If Kadama's at an angle, then isn't it more supposed to be like this or something weird? Kadama's supposed to be doing an angle for you. And then on top of that, the Earth wobbles. At least that's what I remember being taught, like back in college, that the Earth wobbles on its obliquity. So you've got this my professor used to call the squash something else cycle. So the Earth isn't even just like going nice and smooth. The Earth is like, ooh, a little bit of coffee. But the moon, who knows what the moon is doing? Who knows if the moon is wobbling on the obliquity or if the moon is.
Here's this visual just needs to come into this. By the way, anybody who's still on the call, you want to get in on this conversation, just raise your hand. We'll unmute you and you're in. This is what we call some deep geeking out, and we are going. We're going
One of
down a
these days I
rabbit hole
will
right
get my
now.
friend
If you
Tim
want to
join
join us,
tell us all about this, because
Can I just say something that I'm doing that maybe it's not nearly as cool as the direct observation, but it's something that I'm still doing for funsies.
this is good.
I am currently trying to calculate the differences amidst the moon rises each day, like, from one time of day to the next. And I found some really interesting results. Some days the difference between the moon rises is 38 minutes, and then the next 44, then 50, then 56, then 60. So it increases by a certain amount and then abruptly goes backwards as it's doing that.
how long does it take between going forwards and backwards?
That's what I'm
How
trying
long
to
have you
figure
been
out.
computing
I
this?
mean, my estimate's about 2 weeks, but I haven't finished calculating out a full month yet. It's taking me a little while. I mean, okay, this is going to kind of bite, but I'm going to show you what I've got just for a quick second. It's not going to make a whole lot of sense, but we're just going to go with this.
Yeah, see, I would have expected the period between the increasing times and differencing times would have been like a year.
Not exactly done yet.
And you're
but
getting
well,
something that's
Bad
significantly
points for
less
your
than that.
title of this file.
Ha! Yes.
this is what I was doing up at like 3 or 4 in the morning a couple of nights ago and not sleeping. So I was calculating. I'm not done yet. Because,
Oh, wait. No.
but see, look, the difference
Oh,
between
look at
rises.
that.
You see, 9:17 and then 9:55, difference here, 38 minutes, if my math's
okay.
correct. Same, and then the next day it's a 44-minute difference, then it's a 50 minutes,
Okay, that's not
and
what I was
56.
thinking.
And so it goes all the way up here to about 75 and then abruptly drops down to 71 and it goes the other direction. And it's not even at a consistent rate, it drops faster. And then I haven't finished yet, but I'm calculating the number of moonlight hours, and I got impatient and skipped ahead. So it went from 5 hours 16 to over here 13 hours and 19 to over here 11 hours and 21. And I'm going to go see if it does the opposite direction, just for funsies. And then I'm going to try to
For
graph it.
funsies,
Decreasing.
this is cool.
Yeah.
When I'm done with this, I can send it to you.
Oh,
Oh, yeah.
Must be like savings.
And I'm not exactly done with this yet, but I'm also planning to go and do a similar study and compare my times to the time in Svalbard, Norway, and the times over in, I can't remember, Vostok Station, Antarctica, which I've calculated are approximately the same distance, because I can't go with, I can't do South Pole on one and then do like 78 point something or other degrees on the other. I have to do them so that they're both 78 north or 78 south, just to see if there's a difference between who gets the more moonlight hours.
so and by the way, anybody who's watching this, don't. I'm not following it at all either.
Okay, I'll draw it. I'll draw it.
And so if anybody's feeling like you're not alone, it's okay. So again, feel free to like kind of get in on this. I just got it. I need to show people this visual again, just because I love me some NASA, and here's the result of some people doing some hardcore geeking out, which just sort of shows another kind of like, kind of wobble. So this is photographs of the moon to scale, taken night after night after night, making a pattern. And you gotta check this out. Right.
This might be the visual that inspired me to start doing this mapping.
Hide floating meeting controls. Are you ready? Oh yeah, because one thing you're going to notice is that the same face of the moon is facing towards you, but it's more interesting than that, because here we go. Oh, and now you're going back. You really? Oh, look at that. And now where to go? Oh, there you are. Oh, but look at you getting smaller. And then, okay, so we've got this wobble, we've got getting bigger, and we've got getting smaller. But wait, yes, friends, there's more. Because look at how far, let's go for the Sea of Crises. The Sea of Crises is this big black spot. Can you see my arrow? All right. Here's the Sea of Crises. All right, but look at how close it's getting closer. It's getting closer to the edge. Look at that. That's getting closer. It's getting closer. That means you're seeing more of this side. But now watch this side go back. Oh, look, 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 look. So we don't actually just see, we see a little bit more than half the moon as it's going back and forth, because you get to see a little bit of this side and then you get to see a little bit of that side. So you see a slightly more than 50% of the moon in the full course of this.
Oh yes, but the thing is I remember you showing us that quite a few months ago, and I was like, oh, that's so interesting. And now, just recently reading up on this and realizing, oh, of course, the moon has an axial tilt. It doesn't just rotate, perfectly in line with its revolution around the Earth. So now, what I'm thinking is that like the Earth is essentially doing those same wobbles, except much more extreme because of our seasons. And so what I'm thinking is that's essentially the equivalent of seasons on the moon, in terms of like which, sort of where is its axis of rotation relative to its relative to the Earth.
But wouldn't its seasons I'm
not talking about
its seasons are those going to is it going to have those seasons monthly?
Yeah, that's what I'm thinking. Like, okay, so isn't it Uranus is tidally locked basically to the sun, but does have no. That's the one that's like tilted, has a very extreme tilt. What am I trying to think of? Yeah, I'm not sure what I'm trying to say, but I think if the Earth were tidally locked to the sun, but had a very, very small axial tilt, I think that our equivalent of seasons would be the same, which is that you'd have mostly you'd have a sunward hemisphere and a spaceward hemisphere that got sun or darkness all year round, but there'd be a little area along that equator, not I shouldn't say along that terminator, where they get some sun or some darkness, depending, because as that tilted axis sort of it points toward or away from the sun at different parts of its orbit, you'd either have the sun shining on that little itty bitty bit of a ring or not at different times of the year.
I would think too that with the moon, it will still get more of its seasons, because no matter how we move, the moon, like relative to the sun, the moon does turn, just not relative to us.
Yeah.
So
maybe seasons probably wasn't the right word.
Oh no, but I think,
of course, different parts of the moon are illuminated different.
But I think you're onto it because it will get the sunlight on both sides, except that when it's on this side, when it's on the side that faces us, about however many times however many I need to calculate later, there will still be a bit of Earth's shadow on it, so it makes it a little bit harder for it to get quite the same light exposure. Whereas this side, nothing is, except when it's facing away from the sun. But when it's facing towards the sun, then there's nothing standing in the way, unlike us,
right.
and we get
except in the very rare occasion of an eclipse. But I think when I was saying season, I was thinking more along the lines of if our seasons on Earth are measured by how many hours of sunlight we get in a day and what the angle of the sun is for us, then if you sort of think of like a season on the moon as being measured by how much Earth light it gets, or where the angle of the Earth is. I think that was more what I was thinking of. Is basically consider consider the moon's orbit versus its revolution around the Earth, as compared with a planet's orbit and revolution about, that is, a planet's rotation.
When I think of seasons, I'm thinking of.
I probably shouldn't use that.
Of the impact of sunlight on temperatures and all these sorts of things.
Okay, so probably season is not the word I was.
It would be so much easier if the moon just had some water on it.
Yeah.
So here's what I think we need to do.
Have lunch.
I think we should have make a time specifically for kind of getting people together who want to talk about what investigations should we set up of kind of have a lunacy planning meeting, right? And for what things we're going to need people on different continents, for what things we're going to need people in different hemispheres, for what things we're going to need eclipses, and what things we're going to need solstices. Speaking of which, so if you're in the United States, coming up, there are two, in the next couple of years, there are two, an annular eclipse and a total solar eclipse that are going to rock across the United States. And if you get on it now, you can get a hotel and a plane reservation for cheap because they're still available. So so I just want to encourage people to look up. There's a lot of sites online that give you calculators or these diagrams and maps of the paths of the eclipses. And so the first one is an annular eclipse, and then the one after that is a total. And you might want to be in the path of those. And the we just recently made reservations for 2 years in advance, calling up a hotel and saying, like, 2 years from now we'd like to book a room. Okay, sure. But if you move it now, the prices are not inflated and they're still available. Although some people who are a little bit more on top of this than I am, the eclipse is going to pass through Monument Valley. A bunch of the hotels are already filling up there, but then there's also another that is more of logistics to get yourself out there. But consider where you want to be.
Valley is pretty isn't that in or near the Navajo reservation?
Yes.
I think so. It might not be easy to find places to stay.
Oh, there are some cool places. There are hotels in Monument Valley that beautiful views of craziness.
And not gotten to see very much.
So for one, I think we are going to. We were kind of trying to get ourselves out to remote places, but then I remembered that when on the previous eclipse, up in Oregon, roads were closed with people, and so that gets sketchy. So yeah,
just not that I would ever encourage anybody to take a really, really extra long vacation, but if you really wanted to get accurate data, wouldn't you have to book it for like 2 weeks or something? Because I did hear a rumor that within 2 weeks of one eclipse, the other will follow, meaning between 2 weeks of a solar, then a lunar will follow, or vice versa. I'm not sure if that's true, but wouldn't it be a great excuse to take an extra long vacation and study that? Because, I mean, how can you really get accurate data if you take measurements in one place and then you go home and take them somewhere else? Wouldn't you have to stay in the same place to get some really, really comprehensive data?
Although the lunar eclipse can be seen from any place on the Earth, on the nighttime side of the Earth. The solar eclipse you only get to see in one place.
And it would be a fixed amount of time, which is roughly 2 weeks, or maybe exactly, right? Because it's a lunar eclipse must happen on a full moon. Solar eclipse must happen on a new moon.
Right. So here's, I think we should.
We shall take vacations.
We should draw this conversation to a close. I think we should plan a kind of have a Susan and Evea, and send me an email about some times that you might be available for a lunacy planning meeting. And I think we should just have get some lunacy strategery going and see what we can do.
Saw a lunar eclipse through telescope. That's so cool. I've not gotten to. I remember a few years ago.
Wait, hold on. Ray Vonto's got something to share. Nope.
I just in the chat. You're saying they saw a lunar eclipse.
No. And it was just lucky that it wasn't cloudy here that day.
Yeah, I know. This is a problem we have. The last solar eclipse here. There was just no way I was going to be able to get out to where it was a full eclipse. We were able to see the partial eclipse from here, and we did do the like looking in a box with a pinhole, and you could see all the crescent shaped, reflections and things. And I did, and we did look at the shadow of a tree.
That's the best.
Those pinholes of light. That
with
was
all the dancing crescents.
I'm not going to say it was better than seeing the full eclipse, but you see those crescents is just so just weird.
I want us to continue this, but I want to follow Dr. Beast, and let's go make like the moon and get full.
Oh.
Sorry, could not resist.
I think that's a good call. Dear friends, thank you for being here. Thank you for some deep geeking out. More definitely to come. It's fun to be curious about stuff. And then, and also I think it's really useful just to sort of think of kind of old school methods of figuring stuff out, right? How would we go about figuring that out? And yes, the stuff that has already been figured out is really, really useful. And I'm not saying we never turn to that, but
you don't get it as well if you look it up.
I think that there's something about the intellectual process of trying to kind of grapple with the nature of reality and what kind of claims can we make and what is the strength of those claims, and to be embedded in that process of tinkering. It's fun. So thank you all and enjoy your lunch.
Take care.
Bye-bye.